Question 5. A particle starts from rest 2 meters to the right of the origin and moves along the x-axis in simple harmonic motion with a period of 2 seconds. Which equation could represent the motion of the particle? Let's consider the period of motion. Now it's given that the period is 2 seconds. Recall that the period capital T is equal to 2 pi over n, where n is the coefficient or the multiplier of the time variable t. So we need to solve the equation 2 equals 2 pi over n, and we get n equals pi as a solution. Hence, options B and D are incorrect, since the multiplier of the time variable t is not pi. Let's consider this fact, that the particle starts from rest. In other words, the velocity of the particle is 0 when t equals 0. Now all the options show us the displacement equation. In other words, x in terms of t. And when we differentiate the displacement equation, we get an equation for the velocity of the particle in terms of time t. And we want the velocity to be 0 when t is 0. So if we consider option A, the displacement equation involves cosine. So x equals 2 times cos of pi t. When we differentiate this equation with respect to t, we end up with an equation involving sine. And we know that sine of 0 gives us 0, which is ideal. So differentiating x with respect to t, we get v is equal to negative 2 pi times sine of pi t. And substituting t equals 0 for t here, we get negative 2 pi times 0, which of course is 0. So the velocity is 0 when t is 0, therefore the correct answer is option A.